Okay, so today I am presenting power electronics. So power electronics is the main subject for EEE. So power electronics is mainly based on the electronic. So to control the power. So to control the power, we have to use the power electronics subject. So in power electronics subject, all of you know that. So already you have to know the syllabus. So the will first unit will be semiconductor devices. So power semiconductor devices. So in power semiconductor devices, so the topics are semiconductor, power diodes, thyristors, series and parallel operation of thyristors, MOSFET, BJP, all of you there. So first today I am discussing power semiconductor diodes. So already, so semiconductor power diodes we have also seen. So first power semiconductor devices. So in semiconductor devices we have power diodes, thyristors. So in thyristors we have SCR, TRIOC, GTO and power transistor. So in power transistor we have power BJT, power MOSFET and IGBT. So these are semiconductor devices. So in power diodes, thyristors, SCR, TRIOC, GTO, power transistors, power BJT, power MOSFET and IGBT. Okay. So today we will discussing power diodes. So all of you also studied power diodes in EDC also. So in first power electronics we have to study the basics of power diode. So this is power diode. So this is anode and this is cathode. So and this is the power diode symbol and this is the structure. So power diode structure and this is power diode structure, how to pack the power diode. Okay. So this is the packing of diode. So the power diode consists of anode, cathode and it will be current flowing from anode to cathode. So next, structure features of power diode and its symbol. So this is the structure and so this is the structure and this is the symbol. So the from anode positive and cathode will be negative. So anode to cathode the output voltage will be V0. So this is structure. All of you know that diode will have P and N diode. So we have anode positive side, we have applying P will be positive and this is positive region. So P positive and this is we call drift region and this is subtract. So from anode side P positive and cathode side will be N positive. So this is P plus means holes. These are electrons will be moving in drift region. So holes will be P side and N side will be moving. So this region is called drift region. Okay. So next slide. So VI characteristics of signal diode, power diode and ideal diode. So this is the forward bias power diode. So why will how you say the diode will be forward bias means, so when we connecting positive to P anode and negative to cathode, then the diode will be forward bias. So from anode to cathode, so diode from anode to cathode the current will be flowing. Whenever we have given positive to anode, so the current will be flowing from this anode to cathode. So the output voltage will be applying V0. So the diode will be forward bias. So we have to see VI characteristics of signal diode, power diode and ideal diode. So for signal diode, so the VI characteristics will be like this. So here we have to take an output voltage V0 in x-axis and output voltage V0 in x-axis and the current output current will be on y-axis. So the cut-in, whenever we are applying the cut-in voltage 0.7 volts, the diode will be conduction forward voltage. So the gap, this voltage and current, this is called voltage drop. So in reverse bias direction, So the current and voltage graph will be like this, and the VI characteristics of power diode. So these power diodes same, from VI as a signal diode, like this also power diode. So VI characteristics, the output V0 and the current. So the when first the current will be going continuously increasing the current, so from forward direction. So the negative, in reverse bias, the current first will not flow, after that only the current will be flowing. So for ideal diode, all of you know that the current will be flowing only forward bias, not in reverse bias. Okay, so next slide. So these are the reverse recovery characteristics. So reverse recovery characteristics means, so we have to draw output current, output voltage, power loss in a diode. So these are the variation of forward current IF or forward voltage drop, power loss in a diode. So we have to see. So reverse recovery characteristics means first forward current IF. So when you are drawing forward current on y-axis and time will be taken on x-axis. So first of all, so here the forward current IF will be flowing continuously in forward direction for a sinusoidal wave. Whenever in sinusoidal wave, so here the current will be flowing up to this. After that, the current will be decreasing whenever the diode will be in reverse bias direction. So the diode will be in reverse bias, the current slowly decreasing, and reverse bias, the current IRM will be going like this. After that, the current will be comes to zero position. So here from sinusoidal wave to, we have to drawing characteristics for sinusoidal wave. So the current IF will be like this. Here will flowing and it will be coming like this. So here in negative direction TA and TB and TRR. So here the time will be taken for a current to comes to zero. So these are the TRR, reverse recovery time. Sorry. So these are the reverse recovery time from how the current comes from zero position. So these are the reverse recovery time. So the forward voltage drop. For a diode forward voltage drop VF, for, so in forward direction the voltage will be going like this. After that the voltage will be zero. Whenever the diode will not connecting, the output voltage will comes to zero, and in reverse bias some amount of voltage will be going like this. After that it will be comes to zero position. So this is power loss in a diode. So the power loss will be occurring in a diode will be like this. So for sinusoidal wave, the power loss will be occurring from the time reverse recovery time up to this. After that the current will be glowing like this. Okay, so these are the reverse recovery first. So from main class, so today our first class, so that's why I will telling only for power diode only. So power diode means all of you also studied in diode in EDC subject. So we have to introduction of power diode for briefly I will explain that. So tomorrow I will explain SCR operation and remaining things. Okay, so I am stopping. Today our class will be ending. Okay.